Regarding our internal business process perspective, many companies can use different types of techniques for identifying and analyzing quality problems. And we're going to take a look here at 3 distinct ones that many companies do utilize, especially those who have some type of manufacturing process that includes a product or service being put together or manufactured. These types of systems can be ran with computers and machinery. Alright, so 3 techniques that we're going to look at. We have got control charts, a Pareto diagram, and a cause and effect diagram that are highlighted in this particular chapter. With control charts, I've got a visual here for you to look at here in just a second. But basically, it's a statistics-based item where a formal means of distinguishing between random and non-random variations in an operating process. So we're gathering this information and we can analyze it based on the output of the data. Alright, so what we're looking for is, do we see a pattern, and is this pattern not going to be what we are looking for? Is our process in control? Are we meeting our specifications and our standards that we have determined that we want to operate within? So random variations occur. For example, whenever chance fluctuations in the speed of equipment cause a defective product to be produced. Non-random variations occur when defective products are produced as a result of a systematic problem, such as an incorrect speed setting, a flawed part design, or mishandling of a component part. Alright, so what we're going to do is we're going to graph the data. Okay, and you guys should have already seen in your stats class how we can gather this information. We're going to call them observations, and we can literally plot them out on a chart. And we are going to have an upper limit and a lower limit, and we expect our production process to have items within those limits. If we have anything go outside of those ranges, then we have something that we need to take care of. And many times what we're going to be looking for is a pattern. Is the pattern headed towards going out of the range? Because if we're looking like we're going to go outside the range, maybe we need to stop the bus early and figure out what's going on. Alright, so we can use the control chart to monitor what's going on and possibly spot a pattern and do something to fix an issue in advance. So control charts are a graph of a series of successive observations of a particular step, a procedure, or operation, and they're taken at regular intervals of time. So kind of like with your audits when we're taking samples, we're going to be doing the same kind of thing in order to gather this information for our control charts. And as I mentioned, many operations have this built into their production process, and they're monitoring it with computers. They may be using cameras on the assembly line or on the manufacturing process that captures information digitally. For example, I think I've mentioned to you guys that my husband works in the paper industry. They are checking all kinds of things as those thousands and thousands of feet per minute of paper are rolling out of these machines. They can check the water density, they can check the thickness, they can check all kinds of things about the paper, and then they've got ways to chart it and also alarms and things that are set up within the system that somebody doesn't have to actually physically be looking at these graphs as they're put together. They've got the system programmed to send alerts whenever there's an issue. Each observation is plotted relative to the specified ranges. Like I mentioned, we have the upper control limit and that lower control limit, something that has been designed and agreed to in advance, what those limits are, what is that allowable range between that upper limit and that lower limit, and that's what we're going to be looking for. We want our process to be within those two limits or within that range, which we'll talk here in a moment about Six Sigma, but only those observations that fall outside the control limits are regarded as non-random and worth investigating. But like I mentioned, we happen to see a pattern within the control limits that looks like it could be headed outside our limits, then maybe we can catch something in advance of it going outside or out of the control. So looking here at production line A's data, notice that we have our upper limit and our lower limit, which is plotted out here by our top line and our bottom line. And we want to stay within this range. All of our observations are within the range. We're good to go. Notice here on production line B, you can see that we have many observations that are within, but here towards the end, notice that we've got days down here on the bottom of our charts. Towards the end of the 10-day period, you can see that something is going on and we are headed out of our range. We can see that on production line C that all of our dots or observations are actually showing up within our range or within our limits, but do you guys notice that in C that is headed up where it could actually be headed out of our limits? So for production line B, the last two observations signal that a much higher percentage of copiers are not performing as they should, indicating that the problem is probably because of a non-random or patterned out of control occurrence, such as an incorrect speed setting or mishandling of a component part. Right? Whenever we have an issue show up, we want to figure out what the problem is so we can fix it. Again, we've already seen that we have internal failure costs that can be incurred to fix the problem. We want to fix it before it becomes an external failure and goes to the customer. All right, so what all can we do internally to fix it? Production line C illustrates a process that would not prompt an investigation under the rule, but we may be headed out of control. All right, so we can see that there's a pattern there. Why could this particular company have an issue? As the tooling of their machinery deteriorates further, the trend in producing defective copiers is likely to persist until the production line is no longer in statistical control. So we need to take care of these things. Statistical procedures have been developed using the trend as well as the variation to evaluate whether a process is out of control. Now, with our Pareto diagrams, we can take our observations and we can literally count them as to frequency. So observations outside of our control limits are what is going to serve as our inputs for our Pareto diagrams, and they are charts that indicate how frequently each type of defect occurs, ordered from the most frequent to the least frequent. So we're going to basically be looking at a bar graph. So if we go here and we take a look, the number of times a defect is observed is the number of frequencies, number of times. So copiers are fuzzy and unclear has occurred almost 700 times. Copiers are too light or too dark, almost 500. paper gets jammed, copies are not square on page, toner is smudged, paper is not feeding properly. These are the types of defects. Now, depending on how the company wants to deal with these things, we need to somehow prioritize things or issues that we need to take care of. So copiers are fuzzy and unclear. I would say that our customers are not going to jive with that kind of reaction from the copy machine that they're spending lots of money to purchase. So we need to take care of that. Copies are too light or too dark, maybe we need to deal with that one next. Paper gets jammed, folks really don't like those either. Maybe we take care of this one first and this one second, and then this one third, and then this one fourth. Again, maybe we need to put these into some type of order and deal with them. We can take the information from a Pareto diagram and put it on what is called a cause and effect diagram and try to figure out what is the root cause of the defect. What is the problem? Why are the copies fuzzy and unclear? Figure out why that's happening and then fix it. Alright, so if we go and we take a look at our next example, this cause and effect diagram, also commonly referred to as a fishbone diagram, identifies the potential causes of the defects so that we can use it to figure out what is the cause of the defect. So the problems identified by the Pareto diagram or the bar graph chart that we just looked at with the frequencies are used to put to the cause and effect diagrams, breaking out those particular defects. Again, it is called a fishbone diagram many times because it basically looks like the structure of a fish. We are going to see that on our particular one, the copies are fuzzy and unclear. We could have a multitude of reasons why that is. We need to figure out which. So we're basically taking and breaking it down into 4 distinct categories. What are the human factors that could cause that effect or that reaction from our copy machine? What methods and design factors could cause that defect? What machine-related factors could cause that defect? What material or component factors could cause that defect? And then plot them all out and then try to figure out what it is that's actually causing the defect, the fuzzy and unclear copies. So here's what the fishbone or the cause and effect diagram looks at. Notice what some of these categories are. Human factors, poor training, new operator, hadn't really got the hang of it yet. Inadequate supervision. Maybe they have poor training or no training. No one is showing them how the company expects them to do things. Methods and design factors. Is there a flawed part design? Are we doing something in an incorrect manufacturing sequence? You guys have looked at some of those sequence things in operations management. Could it be something to do with our machine? Are they not being maintained properly? Are the machined parts being done poorly? Is it operating at the wrong speed? Many machines have to be ran slow or fast, depending on what the thing is that they're doing. So could somebody have it cranked up too much or running it too slow? And that's what's making the copiers have a fuzzy and unclear copy. Inadequate measurement tools. Have I seen this in the metals industry? You betcha. There are things that people use to measure all different kinds of elements, whether they be volume or dimensions. And sometimes people are using poor tools or tools that have been worn out in order to make measurements of things that have to be cut or poured into a process or something to that effect that can cause issues. Regarding materials and components factors, recall what I've said about procurement and evaluating those suppliers in advance. Could the product that they are sending us, that we are putting into the process, cause our problem? Do we have multiple suppliers? Are we getting the same type of quality from all of those? Is there a variation in those components? Mishandled purchased parts, are we damaging those, or are they coming to us damaged before we put them into the process? And could we have incorrect component specification? So could we have made a mistake in telling our vendors and suppliers exactly what we needed? All right, so using this chart, we could figure out what is causing our problem. All right, so our folks would get together, we would analyze, and we would figure out what's going on. Based on our scenario, management has concluded that mishandling of the steel frame that holds in place various components of the copier, such as the drums, the mirrors, and the lenses, has resulted in the misalignment of these components within the copier, and that's what's causing the fuzzy and unclear copies. All right, so the mishandling of the steel frame within them is the problem. All right, so manufacturers use automated equipment and computers to record the number and type of defects. We've talked about the fact that we can track this information, and these inputs and these computer programs can literally help us spit out all of this information that is going into the charts that we are utilizing. I did mention Six Sigma, and we've talked about other certifications above and beyond the CPA, such as the Certified Management Accountant designation, which this particular class is geared towards our students who want to go and obtain this additional certification. I also want to mention at this point in time that there are lots of manufacturing companies out there. Besides those quality certifications that are obtained company-wide, they are also looking for their employees internally to get certifications geared toward quality. So Six Sigma, you guys can go out there and do some research. You can obtain what's called Green Belt certification and then proceed on through the program and get additional quality certifications on an individual level. All right, so those can help you guys going forward in your career. Regarding some more of those non-financial measures, we've already talked about several in regards to considering the customer's satisfaction and their viewpoint. Many non-financial measures that we can track that will help us to make sure that we continue to strive to improve and, of course, keep those customers satisfied. But we can routinely use some additional non-financial measures to track the quality improvements that we make. Now, again, some of these you're going to see both here and on those customer perspective slides that I showed you earlier. But percentage of defective products manufactured. Okay, so taking the total number of units we produce and having that as our denominator over the quantity that are actually defective. So what percentage of our units produced are defective? If this number goes up, we have a problem. So we better keep our eyes on this number. What about the number of units that are requiring rework? If that number goes up, we have some issues. We have got to drill down and figure out what's going on. You guys have just seen in chapters 17 and 18, normal spoolage, abnormal spoolage. We can talk about taking items and reworking those. If we've got to rework items, we have to invest additional money in correcting things about them in order to turn around and sell them. And that rework can be very, very costly. If you guys were to flip back and look at our example from a few moments ago, back on Exhibit 19.2, our internal failure cost area showed the rework at $100 per hour. If you were to go back and look at some of these other items that were on our list and their cost allocation rate, the rework and the warranty repair had the two highest hourly rate, where design engineering was only $80, process engineering was only $60, inspection was only $40. So consider rework. Many times can be very, very expensive. All right, so if that percentage of products that are having to be reworked goes up, you better start figuring out why we are having to have so much rework. Number of different types of defects analyzed using control charts. If we keep having to add bars to our Pareto diagram, we've got some issues. If we keep having to make more cause and effect or fishbone charts, we have some issues. Why do we have more issues? We need to pay special attention to those things. Right? So improving these measures will lead to greater customer satisfaction, lower our cost of quality, and of course result in better financial performance. The number of design and process changes made to improve our design quality or reduce the cost of quality, these are things that we can also track. Regarding our learning and growth perspective for quality, things that aid us in improving quality, we can look at the experience and qualifications of our design engineers. We can work with human resources to make sure that we are hiring and retaining the folks that we need for whatever the product or service is that we provide, making sure that we have the right folks in place. We can keep an eye on our employee turnover ratio. This is basically the number of employees who leave a company as compared to the average total number of employees typically held on staff. Employee turnover is an issue that many companies have to deal with. Why are we losing folks? Many times it's stated that sometimes it takes as long as 6 months to train an employee, and that's a lot of money being invested into an employee. If they are not staying, why are they not staying? The company has already made an investment into them. What has gone awry? Maybe the training programs need to be improved. Maybe the hiring practices need to be improved. Are we losing them to our competition for pay purposes or work-life balance issues, things like that? So we need to look at things like that in order to work on our corporate culture. What about employee empowerment? This is the ratio of the number of processes in which an employee has authority over to make decisions without consulting supervisors to the total number of processes. So are they being empowered to make decisions, or are we slowing down the process to ask for all types of approval and input from management? We can also look at employee satisfaction. Many companies can take surveys to find out on a yearly basis what is the employee satisfaction ratio. This is the number of employees indicating higher satisfaction ratings compared to the total number of employees surveyed. Employee training, again, percentage of employees trained in different quality enhancing methods. Again, we need to work with HR in many of our learning and growth perspectives on our balanced scorecard. Companies should create a corporate culture in which the employees focus on quality, that managers encourage them to continuously strive to improve quality by identifying and eliminating the root causes of defects. We should measure all of these factors in this learning and growth perspective in the balanced scorecard. Weighing the costs and benefits of improving quality. When faced with a quality issue, managers should evaluate each alternative, identifying the relevant costs and benefits for each alternative. And they need to ask how total cost and total revenues will change under each alternative. We have seen how to utilize the information in that incremental analysis, relevant revenues and relevant cost, and ignoring such things as sunk cost and cost that will not differ amongst the alternatives in one of our prior chapters. We can do that again by using relevant information and trying to decide how are we going to improve our quality, because many times we have alternatives. We can do it this way or we can do it that way. We have seen that we've got those 4 distinct areas, for example, preventative cost, internal failure cost, etc. We can figure out a way to deal with quality issues in one of those 4 areas or spread it around in different areas and try to improve the quality. We know there are going to be costs there, but we have also seen that if we do things a certain way, we can reduce other costs in other areas. All right, so how would we go about reviewing what would occur if we had different solutions available to us? All right, so here's an example that's in our text. Recall that when we looked at that cause and effect diagram or that fishbone diagram, that it revealed that the steel frame of the copier is often mishandled as it travels from the supplier's warehouse to Photon's warehouse and then into the production line. And this particular frame is very, very important component to the copy machine, and it must meet very precise specification or else the components that fit with it do not fit on the frame as specified. So the mishandling during the transportation is what has caused the misalignment and has resulted in that fuzzy and unclear defect that we have a problem with, that our customers are not going to like. Alright, so the engineers get together and they come up with 2 potential solutions. We can either A, electronically inspect and test the frames before production starts. So we're going to have to inspect and test the frames before we can even use them. Or we can B, redesign, strengthen the frames and their shipping containers so that they would better withstand the mishandling during transportation. Alright, so A is going to have cost and B is going to have cost. If we expend those costs in A, it's going to save us money in other areas. If we expend those costs in B, it's going to help us save in other areas. Right, so cost accountants, engineers get together and we can evaluate these alternatives. Therefore, what do we have to do? We're going to have to identify the relevant cost and the benefits for each one of these solutions and focus on how the total cost and the total revenues will change under A and under B and come up with our best solution. Now, we've talked about the fact that if our revenues don't change, then we don't have to consider our revenues. If we have costs that don't change under A or B, then we don't have to look at those. Those things are irrelevant. So, for example, allocated cost, we do not have to go and look at those. All we're going to do is look at the things that are going to change under our alternatives. All right, so notice that here we have, here's A, further inspecting the incoming frames, and then here is B, redesigning the frames. If we go with solution A, it is going to cost us an additional $400,000 for inspection and testing. If we go with B, it's going to cost us an additional $660,000. We are going to have some process engineering, some design engineering, and actually additional cost of the frames, because recall that we said we were going to make them more structurally sound. We're going to strengthen them. All right, so $400,000 versus this $660,000. These are costs. They are showing up as negative because think of the fact that this is reducing our operating income if we do this. However, if we do A, further inspecting them and catching issues in advance means we're going to save money. We're going to save money in rework cost. We're going to save money in customer support cost. We're going to save money in the transportation costs for repair parts. We're going to save money in warranty repair cost. All right, look at what that works out to. 24,000 hours at 40 an hour, 2,000 hours at 20 an hour, 500 loads at 180, 20,000 hours at 45 per hour. If we add all these up, this is quite a bit of money here that is going to be positive. In other words, we're going to shave this back off. We were going to not have to expend these amounts. So if we take this $400,000 and net it against our cost, we will have a net savings or positive contribution margin going for selecting further inspecting the incoming frames solution. If we redesign the frames, we've got those process and design engineering costs plus the additional cost of the frames that we're buying from those suppliers. But we are going to save, we are going to save 32,000 hours at 40 per hour in rework, 2,800 hours at 20 an hour in customer support, 700 loads at 180 in transportation for those repair parts, and 28,000 hours at 45 an hour in warranty repair cost. Extending that out, it's a much larger number in savings. So if we net our $660,000 out or negative towards operating income and add back all of the savings, $3.862 million in savings is way better than $3,090,000 in savings. So we want to do this one because it's $772,000 better result. So we want to tell the engineers to go forward and redesign the frames, and that's going to be our quality improvement project going forward. So cost of quality focuses managers' attention on how poor quality affects operating income. Cost of quality helps managers aggregate costs to evaluate the trade-offs of incurring prevention costs and appraisal costs to eliminate those future internal and external failure costs that could occur. So basically we're talking about making investments. Cost of quality measures assist in problem solving by comparing cost and benefits of different quality improvement programs and by setting priorities for cost reduction. So basically this is management accountants' contribution to the decision-making process. What are the costs? What are the benefits? As long as the benefits received are greater than the cost, we're going to select that particular item, right? Non-financial measures that we have talked about are often easy to quantify and understand. Non-financial measures direct attention to physical processes and to areas that need improvement, and provide immediate, short-run feedback on whether quality improvement efforts are succeeding, or maybe draw attention to the fact that we have got some issues regarding quality that we better take care of. Non-financial measures are useful indicators also of future long-run performance, especially when we consider those ones that deal with customer satisfaction.